In this video, we are going to be learning about conditional statements. A conditional is a statement that is written in if-then format. So let's take a look at an example. It says, if you mow the lawn, then you will earn $20. So we see the word if, we see the word then. That would indicate that a statement can be considered a conditional. And it says, given the statement, two angles that add up to 90 degrees are complementary. It says, how could you write this sentence formatted as a conditional? So if you look at that sentence, two angles that add up to 90 degrees are complementary. There's no word if or no word then in that sentence. So we're going to rewrite it by inserting those terms. So I could say if two angles add up to 90 degrees, then the angles are complementary. So we're essentially getting the same point across, however, it's now in conditional format because we have the words if and then in the statement. A conditional that says if P then Q can be written symbolically as, so the symbol for a conditional is an arrow pointing to the right. So P and Q are basically kind of like a variable, a symbol that we could use to represent different sentences or different statements. So if we're saying if P then Q, we would put P then the arrow, Q, and that would indicate that we have a conditional. P represents the hypothesis. That's the part we're saying if it's true, and Q represents the conclusion. All right, let's take a look at some other vocabulary terms that have to do with conditionals. So there are three. We have an inverse, a converse, and a contrapositive. So we're going to talk about what this means you should do to a conditional statement in words, and then also what it would look like in a symbol format. The word inverse would mean to insert negation. I always remember that because it starts with IN for insert negation. So I'll write that here, insert negation. And what that really means is negate P and Q. In symbol, that would look like our not symbol or negate symbol is this squiggle here. It would be not P, arrow, not Q. So we would read that as if not P, then not Q. Converse starts with CO, so I always remember that as change order. And that would mean that we switch P and Q. So if an initial conditional was P arrow Q, we're going to swap that and we're going to do Q arrow P. Okay, for the contrapositive, that's the combination of both of them. So you are going to negate, and we're going to do both things here, switch P and Q. So again, if our initial conditional is P arrow Q symbolically, then we're going to write not Q, arrow, not P. So we have inserted the negation and we have changed the order. Now there's also something called a biconditional. A biconditional combines a conditional and its converse and uses the phrase if and only if. So that would be the key phrase, the key words that you'd be looking for in order to identify a biconditional statement. So an example of a biconditional would be, you will earn $20 if and only if you mow the lawn. So we would have to see, again, this phrase, if and only if, in order for it to be a biconditional. A biconditional that says P if and only if Q, symbolically we would write as P, and then we are going to have an arrow that goes in both directions, Q. Biconditional statements are true when the conditional and the converse are both true. All right. right, now that we've gotten through all of the vocabulary and the symbols, let's take a look at some sample questions together. All right, I'm going to zoom in here on number 1. It says identify the hypothesis and the conclusion of the conditional below. So it says if you live in New York, then you live in the United States. The hypothesis is the part that follows the word if. So the phrase you live in New York, that is going to be our hypothesis. Whereas, I'll do this in a different color here, if I look at you live in the United States, the part that follows the word then, that's going to be, our conclusion of the conditional. Okay, number 2, write the following sentence as a conditional. Even numbers are divisible by 2. Okay, we have to insert the words if and then. So we could say if a number is even, then the number is divisible by 2. Okay, so now we have formatted this statement as a conditional since we have if and then in there. All right, zooming out to look at number 3 here, it says write the inverse, converse, and the contrapositive of the conditional given below, and then we're going to determine the truth value of each statement. Okay, so it says if a triangle has 3 sides, then the triangle, 3 equal sides, then the triangle is equilateral. Inverse, we're going to insert negation. So we're going to say if a triangle, and we want to still make sure this makes sense when we read it back to ourselves and it sounds like proper English. So we don't want to just say like if a triangle has not 3 equal sides, right? That doesn't sound right. So we're going to say if a triangle does not have, okay, so sometimes there's a little more rephrasing than just putting the word not in there. If it does not have 3 equal sides, then the triangle is not equilateral. Okay, we want to know is the inverse true or false? So let's read it back. It says if a triangle does not have 3 equal sides, then the triangle is not equilateral. Well, that is true. Okay, if there's not 3 equal sides, there's no way for it to be an equilateral triangle. All right, next we're asked to do the converse. Okay, so if, remember change order, CO, change order. If a triangle is equilateral, then the triangle has 3 equal sides. And this is, again, a true statement. If a triangle is equilateral, we know it must have 3 equal sides because of the definition of equilateral. All right, for contrapositive, we're going to combine the negation and the switching of the order. So combine inverse and converse together. So I'm going to say if a triangle is not equilateral, then the triangle does not have 3 equal sides. And once again, this is a true statement. Okay, so really number 3, we practice the terms inverse, converse, and contrapositive and working with conditionals in word form. All right. Our last sample question is number 4, write the conditional and converse form of the biconditional shown below. So we're given this biconditional that says 2x plus 4 equals 10 if and only if x equals 3. All right, so if I want to put this in conditional format, we know conditionals have if and then. So we could say if 2x plus 4 equals 10, then x equals 3. When we do the converse of that, we're going to change the order of those two statements. So if x is equal to 3, then 2x plus 4 equals 10. So when we look at this, first of all, and you could always do this off to the side if you needed to, if x is 3, you can see when I substitute it in here that I am going to get a true statement. So when I have the equation 2x plus 4 equals 10, x does in fact equal 3 when I go and solve that. So for the conditional, when it says if 2x plus 4 equals 10, then x equals 3, that's a true statement. We just showed that algebraically off to the side. If x equals 3, then 2x plus 4 equals 10, and that is also true. So since the conditional and the converse are both true, this biconditional is also true. Okay, hopefully in this lesson you learned a little bit more about conditionals and biconditionals. You can check out the other videos in this playlist to learn more from the logic and reasoning chapter.